You've probably heard a ton about machine learning, right? It's everywhere. But how is it actually being used in chemical engineering? Well, it's way more than just a buzzword. It's a seriously powerful tool that's already making processes better and honestly changing what's even possible. So in this explainer, we're going to break down 5 key ways this tech is transforming the entire field, from the plant floor all the way to the research lab. So here's our game plan. First, we'll get on the same page with what machine learning even is. Then, we'll dive into how it's making the processes we already have way smarter. After that, we'll look at some really cool future innovations, and then we'll wrap it all up by talking about what this means for you as an engineer.
All right, so before we can get into the really cool applications, we got to make sure we have a solid foundation. Let's kick things off with a clear, simple definition of what we're talking about when we say machine learning.
Okay, so here's the key idea. We're not sitting down and coding every single possible instruction. No way. Instead, we're training a system. We feed it a massive amount of data from a plant, historical temperatures, pressures, flow rates, and then we show it what the final product quality was. The system starts to see all these complex patterns on its own, figuring out how everything is connected, even in ways we might not have thought of. It's a totally different way of solving problems.
Now for the really fun part. Let's get into 3 concrete ways machine learning is already out there in the real world, improving efficiency, cutting costs, and making products better, right now.
The first one is a big one: process optimization. You know that chemical processes need incredibly specific conditions to work just right. We're talking temperature, pressure, flow rates, the list goes on and on. Well, machine learning can look at all the historical data from a plant and learn from it to find the absolute sweet spot for running things.
And what this does is create this amazing domino effect. By learning from all that past data, the system can actually predict the perfect conditions to get a better final product. And because it's so good at predicting, you drastically reduce the need for all those expensive, time-consuming physical tests, which, of course, saves a whole lot of time and money.
Our second application is predictive maintenance. Now I know, it might not sound as exciting as process optimization, but trust me, in a chemical plant packed with complex equipment, a maintenance failure is one of the most expensive and dangerous things that can happen.
And this chart just makes the difference so clear. The old way is reactive. Something breaks, and then we scramble to fix it. That means costly downtime, unexpected failures. But with machine learning, we shift to a predictive model. The system is always analyzing data from sensors, looking at past performance, and it can recommend the perfect time for maintenance before something breaks. The result? Less downtime and a much safer and more efficient operation. Okay, let's move on to our third application, quality control. This is where we start applying machine learning not just to the process, but to the actual final product, to make sure it's consistently hitting the highest possible standards. As engineers, we're usually just trying to keep the product within spec, but machine learning lets us aim higher, to consistently hit the best possible specifications. It can even analyze the final product and automatically classify it as first quality, second quality, or waste. That brings an insane level of precision and consistency to the whole production line.
So, we've seen how machine learning is making things better right now. But let's shift gears and look ahead at a couple of more advanced applications that are really going to shape the future of the industry. The fourth application is so important today, using machine learning to design and run processes that are more sustainable and environmentally friendly, right from the very start.
This is really about using data for good. Machine learning algorithms can watch greenhouse gas emissions in real time, pinpoint exactly where a complex process is wasting energy, and even run simulations to predict the environmental impact of a new plant before you even break ground. This lets engineers build greener processes from day one, and it saves a ton of time on manual analysis. And now for our fifth and final application. And this one is just fascinating. We're talking about using machine learning to understand chemical reaction kinetics. Basically, that's the science of how fast reactions happen and why. We're getting down to the nitty-gritty of modeling how individual molecules actually interact and transform. So you can feed an ML model all the inputs, like temperature, the catalyst you're using, concentrations, and it can predict the entire sequence of events. It can model how molecules will bump into each other, how they'll bind together, how they'll split apart, and then ultimately it can calculate the final reaction rate. This is a total game changer, not just for chemists in a lab, but for process engineers trying to optimize reactions in the real world. Okay,
So we've gone through 5 really powerful applications, but let's zoom out for a second and talk about the big picture. What does all this tech really mean for the chemical engineers who are actually out there doing the work?
And this, right here, is probably the single most important thing to remember. This is not about machine learning replacing chemical engineers. It's a tool. It's a remarkably powerful new tool that helps engineers do their jobs better, faster, and with more insight than ever before.
I mean, as one of our sources put it so well, the benefits are just crystal clear. It saves time, it improves efficiency, and it helps get better final products. It's all about augmenting human expertise, not replacing it.
So, as we wrap this up, the main thing to think about is that we're still at the very beginning of this whole transformation. This technology is moving so incredibly fast. The question isn't if it will change the industry. The real question is, how will you, in your job, use this new superpower? What possibilities do you see?